Alright guys, today we're going to go over Chapter 2 of the Engineering Field Manual, Peak Rates of Discharge for Small Watersheds. At your own leisure I would read that whole chapter. I'm just going to go over how to figure out the design flow for a certain watershed. The first thing you're going to have to go through is you have to delineate your watershed. I have two watersheds in here, and today we're going to be designing a diversion for Marlene Barber, and her little watershed delineation is right here. So whenever you're figuring out how to delineate a watershed, all you're going to do is first find the point of interest, which is this green dot, and then you're going to create from that green dot. You're going to just cross through all the contours perpendicular to every contour you come to, go perpendicular. Now at the top of here we got a little saddle, so I went perpendicular across the saddle and then back down, and I started going back around the watershed perpendicular to all the contours. If you need help delineating a watershed, let me know. Guarantee you, if you delineate a watershed relative to someone else, it's going to be slightly different, but it shouldn't be much by much. So I have a 40-acre watershed. So that's the first thing you got to figure out. Get a topog map, delineate the watershed. So I got that done. Now we have a data sheet for doing hydrology, and that coincides with Chapter 2. Everything you'd ever need to fill this data sheet is within Chapter 2. First thing you're going to fill out is who you're doing the data sheet for, the practice name, in this case diversion, and then fill in the rest of the data there. So area is 40 acres. We got to first figure out the curve number. So there's different curve numbers for different types of surfaces. So to be able to figure out this curve number, we go to the back of the sheet, and you have to first find out what type of soils you have. And so to do that, all I did was I went into Web Soil Survey and I delineated the area of concern and figured out what type of soils I have. So all you got to do, go Web Soil Survey, create a little polygon around your area of concern, and it'll give you the types of soil. Once you find out the types of soil, in this case I have Tricky Springs stony loam and Wilcoxon clay loam. You then go and you figure out what group they belong to, and that's in the Chapter 2. So I have all my Chapter 2 tabulated. I highly recommend that, because you're going to be going through a lot of charts. So on here's every soil that you ever talk about. In this case we have Tricky Springs. Just go look for it. It's in alphabetical order. So we're going to go all the way back to the end where there's a T, and Tricky Springs is right. Come on, Tricky Springs. Right here. So it's a type B. So right next to the name of the soil you have what classification it is. So I have a type B and a type C, because a Wilcoxon clay loam, when I looked it up, is a type C. So that's important because different types of soil have different properties. So if you have a type A soil, you're going to have low runoff potential, that's sands and gravels. If you have type B, it's going to be moderate infiltration, loamy sands and sandy coarse loams. If you have a type C, it's going to be slow infiltration, loams, fine sandy loams. And finally type D is type C is a slow potential. Type D is high runoff potential, and that's clays. So that's what I did here. There's my types. Now you got to figure out the curve number. So this diversion we're building it happened during a fire. So originally I sized it using very high curve numbers. The higher the curve number, the more easily water goes over the surface. And then after the fire, we actually did mastication work, at which we put a bunch of we shredded trees on the existing soil, which lowers the curve number. So to figure out the curve number, you're going to go to the chart, and it prompts you on this where you can find it. Well, I'm not on that one, but curve number is going to be table 2-2. I have it tabulated, CN. And so you could either use table 2-2 or figure 2-1. And in my case, I use figure 2-1 because I know that each chart has the type of soil, so there's B, C, D, and I know that I'm a juniper grass area. It's mixed with, so it tells you the area of concern, varying amounts of juniper, pinon grass, and cholla cover. And then I assumed that we had 50% cover. We have more than that, but I just use 50% cover. So there's a cover density. So I'm kind of being conservative. So 50% cover, I could go to 70 or 80 even, because the whole floor of that area has been masticated. So let's go to 50% for juniper grass, and you go up to the type of soil. So for C, I'll go up to 50% type C, go all the way across, it comes out to 73. And then I go to type B, this line, and go across, and it's 64. Not 64, it's 73 and 58. So that's what I put here, 58, 73. Now, to figure out the percent area of acreage, you're going to use your soil map. And when you get a printout from Web Soil Survey, it'll actually tell you what percentage of each soil you have. So this is the printout. So it says that for Turkey Springs Low, that's 31.1% of the AOI, and then for Wilcoxon, 17.6. Because of the fact that the area came up with, this was a different printout actually, but I'm just showing you that so you know where to find the percentage. In my case, for this area, 86.6% of it is Turkey Springs Loam, and 13.4 is Wilcoxon. So you then just take 86.6% of the CN, take 13.4% of the other CN, add them together. So 50.2 plus 9.7. So 86.6% of this is 50.2, and 13.4% of this is 9.7. Add them together, and you get 59.9, and I went to 60. So there's my curve number. So the next thing you got to figure out is your time of concentration, and it's always the longest reach along your drainage. And so we have two charts for that. We have figure 2-3, which is this one. This is for overland flow. So if you're just figuring out water to flow over overland, you would use this chart. If you're going to be figuring out flow going through a gully, you're going to use this chart. So in this case, I used overland flow, and to do that, I first had to figure out the reach. Now the reach you're going to figure out by measuring, and I do this in AutoCAD. Basically, I import this map into AutoCAD, and then I measure from the point of the diversion all the way to the longest reach. And in my case, it came out to 14,404 feet. And then the elevation difference from where the diversion is going to be installed to the top is 220 feet. So you figure that from your topog map. So then I divided 220 by 1,404 to get my slope, and that comes out to about 15%. So when you go on to this overland flow to figure out the time of concentration, you got slope on percent here, velocity in feet per second. I'm going to go to 15%, hit the overland. This is overland flow with forest with heavy ground litter, and that's what mine would be. I'm going to hit the 15 across that diagonal line, go all the way down, and I got 1 feet per second, so I put 1 feet per second. So after that, there's a formula for time of concentration. It's equals TC equals Al over 3,600 times velocity. You're going to multiply, you're going to just put in your Al, this is just to convert from seconds to feet, seconds to hours, and then you're going to put your velocity. I got 0.39 hours. Now you're going to go across and you're going to put a curve number 60, 0.39 for hours. Then CLF, it tells you right here, it's table 2-3. So table 2-3, I have it tabulated. Once again, I can't stress how important that is. For the CLF, it's right behind, right here. So the CLF in my case is going to be 1, and the reason is because the acreage is less than 640. And then I figured out your climatic index, which is a formula CI equals 100 times PA over TA squared. So I did all that here. Now to figure out your CI, you have to know what the normal annual precipitation is and the average annual. And it tells you here, go to exhibit 2.3 and 2.4. So 2.3 and 2.4. And this map is hard to read and you won't be able to see it in this video, but the annual precipitation for the area of concern in my case was 20 inches. And basically this map just has gradations, almost like a tobog map, that has the lines correspond with how many inches, annual inches precipitation they get. So after I found that my annual was 20 inches, then I had to find the TA, which is the average temperature in the area, and I found it to be 50 degrees, and that can be found on let's see where that one was. That can be found on exhibit 2-4, so it's right behind it. Same thing, you just find the temperature that correlates to as approximate as you can to the closest area in concern. In this case, all I did was, it's near estancia, so I found the contour that's close to that, and it's about 50 degrees average, just west of that, because that's where the site is, near the mountains. So that's that. Then for unit discharge, you have to go to figure 2-4. And for 2-4, it's right here, you're going to figure out your unit peak discharge. So we already know what the TC hours is. In my case, the TC was 0.39, so I went to 0.39. There's 0.3, 0.39, go across and down, and I got I came up with a 1.1 CFS per acre inches. So for the diversions, we're going to design them for 10-year. So next thing you have to look at is exhibit 2-2. Exhibit 2-2 is basically a map, and we're going to do the rainfall for 24 hour. It's typically what we do. 10-year, 24 hour for diversions. If you need to know what you're supposed to use, look at the standards and specs. So on this map, you got to remember that it's in tenths of an inch, and so what I did was I went as close as I could to the area in question, and which is near Estancia. I used the Manzano Mountains, and I used this contour here, which says 25. Like I said, it's tenths of an inch, so it's 2.5. You have to remember that's important. So I put 2.5 here, and then the direct runoff is from figure 2-5. So let's go to figure 2-5. Oh, shoot. Figure 2-5. There we go. And that's this guy here. So 2-5, you're going to use the rainfall in inches, which is 2.5. I found 2.5, there's my line. Then you're going to go up to your curve number, which ours is 60. Go all the way down to where it converges on there, and then go across over here to the direct runoff. And I got 0.2. So then the net runoff, it tells you to multiply your direct runoff, which you just found, times CLF, which you also have up here. So it's 0.2 times 1. And then the peak discharge is going to be CFS 40 times acres times QN 0.2 times CFS per acre inch 1.1. I get 8.8 CFS.